All right, let's take a look. A total at a coffee cup calorimetry part A. A total of 2 moles of a compound is allowed to react with water in a foam coffee cup, and the reaction produces 116 grams of solution. The reaction causes the temperature of the solution to rise from 21 to 24.7 degrees Celsius. What is the enthalpy of this reaction? Assume that no heat is lost due to the surroundings or the coffee cup itself, and the specific heat of the solution is the same as that of pure water. So we have a reaction here where substance X plus water react in such a fashion that they yield compound Y. We don't know what compound they yield, but we know that there's a change in enthalpy, and that's what we're going to solve for. In order to solve for this change in enthalpy, what they've given us is information to solve for Q. So we have a heat flow due to the reaction that we carried out. We then have a heat flow into the solution in our calorimeter. And according to the first law of thermodynamics, the sum of our heat flows always has to be equal to 0. We're going to solve for that heat flow of reaction. We know that the heat flow of our solution is causing or producing warming or cooling. Crap formula. So now it's plug and chug. So now we plug into our calculator. And let's see here. 24.7 minus 21 equals times 1116 times 4.184 gives us a calculator lie of 1,795.7728 joules. We're going to solve for the Q, X, and R, so we're going to have to swing it around to the other side of the equation to get it to equal to Q. Okay, so that's for our joule. We need to convert to kilojoules because that's what they're wanting on, I think we need to convert to kilojoules, so I'm going to go ahead and do that. And that gives us 2, 3, Now, this is not our final answer. This is just the amount of heat released for what we actually reacted. We want this to be in terms of heat of reaction, which is always kilojoules per mole. So we have to take this Q and R, delta H is going to equal the Q of the reaction divided by the number of moles we actually reacted. In this example, they made it easy for us by giving us 2. So it's going to be a negative 1.796 kilojoules divided by 2 gives me a delta H of 0.898 kilojoules per mole. And that's it. Chemistry is easy, life is hard. There should, of course, be a negative there. I did not mean to drop the negative, so let me make sure that you see the negative there, right? Negative. Negative 0.898 kilojoules per mole.